Hey guys. So this problem is almost exactly the same as the last problem we did. The only real difference is the wording and the actual numbers that we're using. So I'm going to move a little bit quicker in this one. So we have everyone's least favorite Avenger throws his bow off of a bridge. He throws it upwards at 30 meters per second. The bridge is 40 meters off the ground. I want to know, what is the maximum height of the bow? How much time passes before the bow hits the water? And what is the velocity of the bow when it hits the water? All right, so once again, let's draw a quick little picture. We've got a bridge here. We're throwing a bow off of it, hitting the water below. So this distance right here is 40 meters. Our initial velocity is 30 meters per second. We know, because it's a free fall problem, that the entire way through we are experiencing negative 9.8 meters per second squared. I'm assuming that the water is my zero mark. I'm assuming up is positive and down is negative. Okay, let's set up our equations and our variable lists. S equals xi plus vit plus 1 half at squared. And a is equal to vf minus vi over t. Great. And we have another two-parter. So part A is going to have s, xi, vi, vf, a, t. Part B is going to have s, xi, vi, vf, a, and t. We'll just mark that off so I don't run over into it again. So let's go ahead and get our initial values. So for part A, that's this part right here, here to here, we have an initial velocity of 30 meters per second. He throws it upwards at 30 meters per second. We have the bridge being 40 meters off the ground. That means our xi is going to be 40 meters because we set our water level as 0. Our s, we don't know. Our acceleration, we know because it's a free fall, is negative 9.8 meters per second squared. And our vf, our final velocity, we know that because this is being thrown upwards, has a positive velocity and a negative acceleration, it is going to continue slowing down until it reaches 0 velocity. So our vf is going to be 0 for part A. So let's go ahead and figure this out. We want to know S. That's our A question. But in order to find S, we're going to need to find T. We know that because we have an xi, we have a vi, an a, but we're missing a t and an s. So we have to use our other equation because we have an a, we have a vf, we have a vi, we can use that to solve for t. So let's go ahead and set that up. Part A, first, a equals vf minus vi over t. Rearranging to solve for t, that's just going to be t equal to vf minus vi over a. Are you guys starting to get used to these rearrangements that we're doing kind of frequently? I hope so. So, substitute in our values. Vf, 0, minus a Vi of 30, all over negative 9.8. So, negative 30 divided by negative 9.8. It's going to give us a value of 3.06. .06 seconds. So T1, 3.06 seconds. Great. Now we can plug that into our S equation and solve for our displacement, for our maximum height. So S equals xi plus vit plus 1 half at squared. I have xi, that is going to be 40. I have vi, that's going to be 30, times my time of 3.06 plus a 1/2 negative 9.8 times 3.06 squared. Great. Now, let's just punch that whole thing into our calculator. Nice and simple. Okay, our answer is going to be 85.92. 85.92. It was 0.918, but I'm rounding up to the hundredths position. And that's going to be in meters. So that's going to be our S. So 85.92 is our answer for part A. All right, how much time passes for the bow before the bow hits the water? Well, in order to find that, I need to find T2. So I need to set up my part B. So let's go ahead and box this guy off so I know not to use that space. Now, part B, my S. What is my S for part B going to equal? Well, I know the end of my motion. The end of my motion that I'm tracking is when it hits the water. What displacement is the water? What position? 0. So S is going to be 0. Nice and simple. Hey, look at that. My XI, remember, my final conditions from part A are going to be my initial conditions for part B. So XI is going to be my former S. So 85.92. My VI is going to be the same as my previous VF, which conveniently is 0. My VF, I don't know. That's what I'm trying to find in part C. My acceleration is going to be the constant 9.8 meters per second squared. All right, so I can use all of this information to solve for T, because I have an S, I have an XI, I have a VI of 0, which is going to drop me out there, and I've got an acceleration. Perfect. So let's set up our part B to find time. So S is equal to XI plus VIT plus 1/2 AT squared. Substituting my values in is going to be 0 is equal to 85.92 plus velocity drops out. Let's simplify our 1/2 A right away. That's going to be negative 9.8 times 1/2. It's going to be negative 4.9 T squared. All right. Moving our 85.92 to the other side, we get 85.92 is equal to negative 4.9 T squared. Divide both sides by negative 4.9. That's going to give us a value of 17.53. Notice it's positive, which is good because we're looking for time, and that's T squared. We need to square root both sides. And that's going to give us a T of 4.187, so 1.19 seconds. Okay, so our T2 is going to be 4.19 seconds. Great. And now that I have this information, I can finally solve for my final velocity. Okay. So part B, A equals VF minus VI over T. I want to solve for final velocity, so A times T is equal to VF minus VI. VI is 0. Get rid of it. So I'm looking at A times T. So, fantastic. I'm looking at a 41.06 negative is equal to VF. Box her off. And then all I have left to do is find my total time. So T total is equal to T1 plus T2. So T total is 3.06 plus 4.19. That's going to be 7.25, sorry. And there you have it.